These notes will cover relations and functions. There are four ways to represent a relation, which is a set of pairs of input and output values. So one way is a graph, ordered pairs, table of values, and a mapping. So for example, I'm going to choose a few points from this graph. So let's say this one here, x is -1, 2, 3, 4, 5, and y is +1. So you'll see it on the ordered pairs, -5 and 1. On the table, -5 and 1. On the mapping, -5 and 1. Let's choose the next point here, farthest to the left. X is -1, 2, 3, and y is -2. So x is -3, y is -2, -3, -2, and the mapping -3 and -2. One more point. So this point here, x is -2 and y is 1, 2, 3, 4, 5. So -2 and -5, -2 and -5, -2 and -5, and the mapping -2 goes to -5. So as you can see, it's just four different ways to represent a relation. Also, I'm going to just mention this real quick. If you look at the table of values on the y or the outputs, you see that -2 repeats on the table and also on the mapping. Okay, so there's a -2 here and also -2 there for y. But when you list the domain and the range, if any value repeats, you only list it once. So the y values are the range. So that means this -2, notice that it's only listed once, and also on the mapping, you should see that -2 goes to, -3 goes to -2, and 5 goes to -2, so it's only listed once on the range. Very important, you should write this down. Whenever you do or you list the domain values and range values, you need to start from least to greatest for both. So domain, least to greatest, range, least to greatest. Now, let's go over a few definitions for functions and relations. So domain is a set of inputs, also called x-coordinates in a relation. The range is the set of outputs, also called, I'm going to have to use this one here, also called y coordinates in a relation. A function is a relation that has only one y value for every x value. In other words, the x value, or in the input or domain, cannot repeat. Okay? So let's go over a few examples that demonstrate what I just said here. So let's list the domain and the range of this function, or of this relation. So domain, and I'm going to use set notation, and range. So domain, we start from least to greatest. The least of these two values is a -5, and then the -4. And the range, the least is a -3, and then -2 and -1. Now the next question is this relation a function? Well, from the mapping, as you can see, -5 goes to -1 and also -3, which means that it repeats. So the x value of -5 repeats, so we say non-function -5 repeats for x. Okay? So let's go to the next example. So this one here, I'm going to list the x values, so I'm just going to underline them real quick. So domain, and I'm going to start from least to greatest, so that's -4, -2, and then +1 and +2. Now the range The range is least to greatest, so 3, 5, 6, 8, and 9. Now, is this relation a function? Well, as you can see, the 1 repeats, so that means non-function, and we say that the x value of 1 repeats. Okay, now the next one, this one is a graph, so this one might be a little bit more challenging. So let's look at the values for each one of these points. So I'm going to start from the left, farthest to the left, so domain, and the farthest to the left is this point, so x is negative 1, 2, and 3. So negative 3, the next one is this one here, so x is negative 1, 2, negative 2, and the next one is this one here, where x is 0, and the next one is this point here, where x is 2, and the next one is, I have 2 points, where x is 4, so that means it repeats, and the last one is this one here, where x is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and the range. The range, now I look at the lowest value for y. So this is the lowest point, so that's where I start. So y is negative 1, 2, 3, 4, 5, and 6. So negative 6. And then the next point is this one here. So y is negative 5. And the next one is this one here, where y is equal to 0 right on the x-axis. And the next one is here, where y is positive 2. And the next one is this one here. So 1, 2, 3, 4. Y is 4. And this one here will be the next one. So y is 1, 2, 3, 4, 5. And the last point is y equals 1, 2, 3, 4, 5, 6, 7. Okay, now is this a function or not a function? Well, we can see that the x value of 4 repeats, so that means non-function. X value of 4 repeats. Okay, so let's go to the, now let's discuss the vertical line test. So the VLT states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. Okay, so let's look at the first example. So if I assume that this is a line, if I pass this line at every single point on this graph, it's only going to intersect that graph at one point. So that means this is a function. Okay, because it passes the VLT. The next one here, this line crosses this graph at 2 points on many places or many points. So that means this is a non-function because it doesn't pass a vertical line test. Now, next example, on this graph also, if I place this line at any point on this graph, it only intersects that graph once, so that means this is a function, okay? Because this one passes the vertical line test, this one also passes it, but this one doesn't. So that's how you can tell by looking at the chart whether a relation is a function or not. Let's go now into function notation. So function notation, f of x equals means the same thing as y equals, but using f of x just shows that the equation represents a function. So since the equation y equals 2x plus 3 is a function, we can instead use f of x equals 2x plus 3. Now, to find f of negative 1, we would substitute negative 1 into the equation whatever we see on x. So that means instead of x, we would plug in a negative 1 right there. Okay, so let's go over a few examples for this. So example number 1, what if we have the equation f of x equals x squared plus 4x? So f of negative 1/3 equals, instead of x, I'm going to plug in or substitute a 1/3, and I'm going to square it. So plus 4 times negative 1/3. Okay, now don't forget, whenever you square a number, let's see, it's this is negative 1 third times negative 1/3. That's what it means to square a number. So 1 times 1, so f of negative 1/3 equals 1 times 1, it's negative, so that should be 1. And 3 times 3, that's 9. So this becomes 1 over 9 plus this 4 is over 1, so 4 times 1, and this one is negative. So I'm going to just change that sign and make it minus. So minus 4 over 3. Now again, we just got done working with these type of problems, which is fractions, and as you can see, we don't have the same denominator, so that means we need to multiply this one here. We want to turn that 3 into a 9, so we multiply by 3 top and bottom. So once we do that, f of negative 1/3 equals 1 over 9 minus 4 times 3, that's 12. And now we do have the 9 in the denominator, so now we can add those two fractions or subtract those two fractions. So f of negative 1/3 equals 1 minus 12 is negative 11 over 9. Now you might feel like, oh, I'm done, but we're not, because don't forget, we're trying to find whenever x is negative 1/3, what is the value of y? And that is a point, so we need to write the coordinates. So when x is negative 1/3, y is negative 11/9, or negative 11 over 9. And now we're finished with this one here. Okay, so let's go on to the next example. So this is g of 7 over 12. So we're trying to find whenever the value of x is 7 over 12, what is the value of y? And now we're looking at this function. So that has a 5 and minus 3 times, instead of x, 7 over 12. Okay, so this one here, again, g of 7 over 12 equals 5, and then I'm going to write a 1 under that 3, and then this 3 and that 12 reduce. That 3 becomes a 1, and 12 divided by 3 is 4. So then I just end up multiplying minus, so 1 times 7 should be 7, and 1 times 4 is 4. Okay, now this has a 4 and this has a 1, so that means I need to multiply. I'm going to try to squeeze this one in. I don't have much space, but I'm going to try to squeeze it in, so that means I need to multiply this by 4 so that I have the same denominator. Okay, so this is g of 7 over 12 equals 4 times 5 is 20, 4 times 1 is 4, minus 7 over 4. So now this is 20 minus 7, that's 13, and 13 over 4. So we found whenever x is 7 over 12, y is equal to 13 over 4. So the coordinates are, when x is 7 12ths, y is 13 fourths. Okay, and there are the coordinates of that point. Okay, one last example here. When g is negative 2/3, so again, we're looking at this function. So g of negative 2/3 equals, so that means 5 minus 3 times negative 2/3. And again, that 3 and this 3 reduce, and this is 3 over 1. So that's 5. And this is negative times negative, so that's going to change to positive. So this is a 1 instead of a 3. So 1 times 2 is 2, and 1 times, and this also becomes 1. So that's 2 over 1. So this is just 5 plus 2, which is 7. So g of 2/3. So whenever x is negative 2/3, that means y is 7. And we're done. Okay? See you in class. Bye-bye.